want to find the extreme values for y equals 2x squared minus 8x plus 9. So this one I'm going to be taking the derivative, which will be 4x minus 8. I'm going to set this equal to 0 to get x equals 2. So my critical point will be at x equals 2. I can classify this using various different ways. If one thing I can do is notice that this is a quadratic with a positive coefficient, so it's going to open up. And here, clearly, x equals 2 will be a minimum. And plugging it back into the equation for x, I get that y is equal to 1. So at x equals 2, we get a minimum, and the minimum itself is going to be 1. The other way to do it is to use the first derivative test. We're going to do a number line here with our critical point. We're going to test numbers to the left and the right. I'm going to pick 0. Plug it into my derivative here. I get a negative number. And then I'm going to pick a number right of 2, we'll say 10. I get a positive number. So from the left of 2, it's decreasing. The right of 2, it's increasing. So the minimum occurs at x equals 2. And then the other way to do this is to find the second derivative test, which the second derivative is 4, meaning it's concave up, so there has to be a local minimum. Similar to what I said in the beginning here. All right, next, given y equals x cubed minus 2x plus 4. So find the first derivative, set equal to 0. Okay, now I'm going to add 2 to the other side, divide by 3. And here I'm going to have to take the square root of both sides. And because I'm taking the square root of both sides, I have to do the plus or minus. Otherwise, I'll be losing one of the critical points. To do this very quickly, I'm going to look at the second derivative, which will be 6x. And if I plug in the positive root 2 over 3, I get 6 times root 2 over 3, which is positive. So that means it's concave up, like the graph, so it has to be a local min. And then if I plug in negative root 2 over 3, I get a negative number, so that's going to be a local maximum at x equals negative root 2 over 3. And if I plug it back into the equation, the local minimum will be negative 4 root 6 over 9, and the maximum will be 4 minus 4 root 6 over 9, and this maximum will be 4 plus 4 root 6 over 9. So this is just a matter of plugging root 2 over 3 and negative root 2 over 3 in for x here to get what y is. Okay. So that part I recommend to use a calculator. Okay, next we'll be looking at y equals x cubed plus x squared minus 8x plus 5. I'm going to take the first derivative of this, and I'm going to set this equal to 0. This one is nice enough where we can actually factor it. So how do you get 3x squared? That's going to be 3x and x. How do you get negative 8? Well, 8 is 4 and 2, so we're just going to leave it like this, and this should work. Okay, so we factored out the first derivative. Now we're going to set each factor equal to 0. We get x is 4/3 and x is -2. So those are our critical points. Now we want to classify them. So I'm going to take the second derivative, which will be 6x plus 2. Now I'm going to plug in my two critical points. Let's plug in 4/3 first. We get 6 times 4/3 plus 2, which you're multiplying by positive, adding by positive. I don't care what this value is, it's going to be positive. And if I plug in -2, I have 6 times -2 is -12, plus 2 is -10, and we find that it is negative. So the second derivative is positive, meaning there is a local min, and it being negative, it's concave down, is a local max. Okay. So always, if you forget which one is which, for the local min or max, just know the second derivative tells us about concavity, and whether it's concave up or down tells us if it's a min or max. And the last step is to find what the actual maximum and minimum value are. So for the maximum at -2, it's going to be 17. And the minimum at 4/3 is -41 over 27. So those are the minimum maximum values. All right, next let's look at x cubed times x minus 5 squared. This one we're going to require to use the product rule. So take the derivative of x cubed, multiply that by the second function, plus take the derivative of the second function. So we're going to use the chain rule, bring down the exponent, keep the inside the same, subtract 1 in the exponent, multiply by the derivative of the inside, and then we're going to multiply it by x cubed. Okay, so next, I don't like the way it's written, so I'm going to try to bring it all together by factoring. Okay, so that should always be on your mind after you take the derivative. Can you leave it in factored form? So I'm just going to look at what I need, or what they have in common. So you have an x squared and x cubed. Pick the smaller exponent. Then I have x minus 5 squared, x minus 5. We'll keep x minus 5. Now what's left will be 3 times x minus 5, and then plus 2 times x. So simplifying further. Okay, so I'm going to do an intermediate step. I'm going to distribute the 3 to get 3x minus 15. And then I'm going to add that to 2x, which will be 5x minus 15. And then I can set it equal to 0 now, because I'm happy with how it's with the factored form. Set each factor equal to 0 to find the critical points. I get x equals 0, 5, and 15. Oh, sorry, not 15. 3. So 3 is my critical point. Okay. Next step will be to classify the critical points. In here, it doesn't make sense to use the second derivative test because taking the derivative again is just a pain. So we're going to use the first derivative test. So we'll use the first derivative test. And we're going to put all our critical points on here. I'm going to rewrite my derivative because I can't see it. So, and actually I'm going to factor out a 5 here. So that'll be x minus 3. That might be easier to work with. So this is how simple it is. Pick a point less of 0, say -1. How about between 0 and 3? 1. Between 3 and 5, we'll say 4. Between 5 and infinity, just 10. So let's do -1 first. Okay, so 5x squared is always going to be positive unless you're plugging in 0, which we're not. So we can ignore the 5x squared. And now we can simplify it to just x minus 5 and x minus 3. Okay, if I plug in -1 into x minus 5, I get a negative. And then I get another negative for x minus 3. 2 negatives make a positive. If I plug in 1 now, I get a negative and a negative as well. So 2 negatives make a positive. If I plug in 4, I get 4 minus 5 is negative, 4 minus 3 is positive. A negative and a positive will be negative. Finally, I plug in 10, and I get both are positive. Positive times positive is positive. So now what's happening is to the left of 0, the derivative is positive. It's going up. Then it's going to 0, then up, then down, then back up. So over here, there's no change in whether it's increasing or decreasing. So there is no extrema here. Okay, at 3, so to the left of 3 it's going up, right at 3 is going down. So there is a change there. So this looks like a maximum. So the local max at x equals 3. Okay, at 5 it's going down and then back up. That looks like to be a minimum. So there's a minimum at x equals 5. Now we have to just plug it back in. And if I plug in x equals 3, I get 108. And if I plug in 5, I get 0. And that's my extrema.